Good morning. Can you guys hear me?
Yes.
We're starting right on time. Minority Report is real. Pre-crime is real. I love science fiction movies, and after watching a science fiction movie, I'm always left with the thought, now did the movie inspire the technology, or did the technology inspire the movie? So I have a case to share with you today where the movie actually inspired a practical use of the technology. So let me show you a clip.
Jad, what's coming?
Double homicide, one male, one female. Killer's male, white, 40.
Set up a perimeter and tell them on route. I'm placing you under arrest for the future murder of Sarah Marks. Give the man his hand.
The future can be seen.
All we have to run on are the images that they produce.
We see what they see.
There hasn't been a murder in 6 years. There's nothing wrong with the system. It is perfect. I agree.
Murder can be stopped.
Tell me exactly what it is you're looking for.
Flaws.
You ever get any false positives? We are arresting individuals who've broken no law.
But they will.
The fact that you prevented it from happening doesn't change the fact that it was going to happen.
The system can't be wrong.
You say something, Chief?
No. You're in a lot of trouble, John. I have a warrant in my pocket that says murder.
Don't run.
You don't have to chase me.
From 20th Century Fox
He set me up. He set me up.
and DreamWorks Pictures.
Who's the victim? I've never heard of him, but I'm supposed to kill him in less than 36 hours.
He's coming here to get her. Tom Cruise
I need your help. Keep contained information. I need to know how to get at it.
in a Steven Spielberg film.
I have to know. I have to find out what happened in my life. You tell me, who was it that set this up?
I don't know.
How about now?
On June 21st, everybody runs.
I love you.
Minority Report.
Okay, who's seen that movie? I love that movie. It is my favorite movie of all time. And so I've seen it a billion times. So this movie is the inspiration for what we're going to talk about today. For those of you who have not seen the movie, it came out way back in 2002, and it stars Tom Cruise, and it was set in 2054. And so it introduces this concept of pre-crime. So this is where a criminal is arrested right before they commit the crime because the police officers know a crime is about to occur. And in that movie, they talk about pre-crime, predictions, and I started thinking, so what technology do we have today that can make predictions? So in the movie, they use psychic technology, but in this day and age, we have machine learning. So in the movie, we have pre-crime. And pre-crime is like foreknowledge, so you know ahead of time what's going to happen. And like I said, that's machine learning. So what are we going to talk about today? So today we are going to look at pre-crime in 2018. We'll talk about machine learning concepts. I'll give you a high-level overview. And then we'll look at how we implement machine learning using Amazon machine learning. I will introduce you to a very cool case study, and I'll talk about the social implications of computing, machine bias, and then I'll have a Q&A. Now, before I get started with machine learning, let me tell you a little bit about myself. So my name is Kesha Williams. I'm sure almost all of you in your head, you were calling me Kesha, but it's not Kesha, it's Kesha, but that's the story of my life. I currently work at Chick-fil-A now. Who's heard of Chick-fil-A? Okay, a few of you. Well, Chick-fil-A is an American-based fast food company that sells the best chicken sandwich in the world. So if you're ever in the United States, you have to try Chick-fil-A. I've been with the company for about 13 years now, so a pretty long time. I currently really have two roles there. So I have what I call my day job, and I have my night job. And so my day job, which is boring, I am a full stack web developer. So on the front end, I work with Angular, and on the back end, I work with Java and Spring. Now that's the boring day job. Now the night job, the fun part of my job, I actually get to lead innovation teams as we research new and emerging technologies like machine learning, IoT, facial recognition, virtual reality. So I lead teams and we build prototypes, just testing out the new technology to see how it can improve restaurant operations and customer experiences while inside and outside of the restaurant. And so one team that I recently led, we won the Think Different Innovation Award for using artificial intelligence. So a lot of the lessons learned I'll be talking about here today. Now, I also invented a pre-crime predictive policing machine learning algorithm, so inspired by Minority Report, and that's our case study for today. So we'll crack open the code on that case study. Now, on a more personal note, my husband is actually from London. So he grew up in Maida Vale. I've been here many times. I love the city. And he does tell me on an almost daily basis that as an American, I butcher the English language. So let the butchering begin. So what is machine learning? So the technical term, the official term, it's a subfield of computer science. It was coined way back in 1959 by Arthur Samuel, and it gives computers the ability to learn without being programmed. So what does that really mean? In layman's terms, the type of machine learning that we're going to talk about today, it's a program that basically analyzes past data to make predictions about the future. It's a pretty simple concept. We all have heard the phrase that past behavior is a good indicator of future behavior. And so that's what machine learning does. And so the program finds patterns in historical data, and it builds a mathematical model. And then that model is used to answer new questions or make predictions when new data arrives. Now, machine learning can help you understand historical data to make better business decisions. It's really cool. So, general uses of machine learning. Now, when I first started learning about machine learning, I was really surprised to learn about where it's all used today in society. So who knew that sometimes whenever you apply for a loan, a car loan or a home loan, there's a machine learning program that makes a prediction on whether or not you'll default on that loan. And then that may say yes or no if you get that loan. Employee hiring, who's heard about that? I was surprised to see that there are some companies that use machine learning to see if you'll be a good fit for a company you're trying to work for. Healthcare. Now, this one is really amazing because it's actually life-saving. So there are some machine learning programs that are really good at predicting certain forms of cancer long before a diagnosis. Now, that is, like I said, life-saving and pretty amazing. It's also used in personalized marketing, recommendations. Who in here has Netflix or Hulu? So every time you log into Netflix, it's always recommending a new TV show or a new movie that it thinks you may enjoy watching. So there's a machine learning algorithm behind that prediction. It's used to combat financial crimes. So there are machine learning algorithms that study past financial transactions that you make, and whenever it notices something that's out of the ordinary or an anomaly, it helps identify fraud. So that's called anomaly detection. That's really cool too. and then law enforcement and in the courthouse. Now this one, I was literally blown away when I learned that there are some judges in the United States, I'm not sure about over here, but they use machine learning to help to predict whether or not someone will be a repeat offender. And unfortunately, if the machine says, yes, you're going to be a repeat offender, you may not get out on parole. And so that was really mind-blowing when I heard about that. So machine learning is used all over the place. Now, machine learning can be applied, like we just saw, across so many domains. And it's really good when you're working with large data sets. So there are too many records for you to manually review. So for example, if you're looking at 10 emails and you're trying to determine if they're spam, it's easy as a human to review 10 emails. But what about thousands of emails? That's just not humanly possible. So a machine can help with that. So when the rules can't be coded because there are just too many factors that influence your decision, machine learning is good for that. And then also data-driven learning. Now, what machine learning is not? So when I started learning about machine learning, I oftentimes confused it with business intelligence. Who's heard of BI or business intelligence? Right, so business intelligence, the way I think about it, it deals more with the past. And it gives you charts and graphs where you can visually see your data, and you as the human, you make decisions. So I have a chart showing up here, that's a BI chart. And it can answer questions like, what percentage of crime in the state of Georgia, that's where I'm from, in the United States, happens in Cobb County? That's the BI question. Calculate the number of vehicle thefts versus assaults. That again is a BI question. Now machine learning answers the types of questions like, what's the likelihood of a crime occurring in this county at this time of day given these circumstances? So when we talk about future, what can happen in the future, that's machine learning. So machine learning can do amazing things, but there are instances where machine learning would be an overkill. It's like taking a sledgehammer to a nail, it's just a bit too much. And so when simple rules work, simple computations, when you have predetermined steps that you can code ahead of time and the steps will always be the same, that's when you should not use machine learning. Now let's talk about predictive policing. Who's heard this term? It's a really hot topic right now. And so predictive policing uses predictive analytics, i.e. machine learning, to determine the likelihood of crime. And it's called an innovation that's capable of stopping crime before it starts. Now, I don't know about you guys, but that sounds exactly like pre-crime to me. And there was an article published last year by Stanford University. It's a very good article. I recommend that you guys read it. It's called Artificial Intelligence and Life in 2030. And so in this article, they talk about how within the next 15 years, society will heavily rely upon predictive policing. So I started doing more research about this field, and I was really surprised about what I found out. So I mentioned to you earlier about judges using machine learning in the courthouse. So this was a study done by the University of Pennsylvania, and they found a 50% drop in new domestic violence cases because machine learning was used in the courthouse. That is a big number. UK Metropolitan Police. Have you guys heard about the hotspot maps? So the UK Metropolitan Police, very close to home, uses machine learning to produce hotspot maps. And so the hotspot map shows an area in the city where crime is likely, highly likely to occur. And so forces are then deployed to those areas with the hopes that it would reduce crime with the increased police presence. And so the number is a 26% drop in violent crimes using machine learning. That's pretty amazing. Even in Pittsburgh, Pennsylvania, the police department uses something similar to the hotspot maps. Here in this picture, you'll see the police officers driving around in his car with a computer. And so that computer is running machine learning, telling him where he needs to go in the city to patrol. So it's the same concept of a hotspot area, an area where crime is likely to occur. Even in Chicago, now this one did not go over well. So by show of hands, who's seen it's an American TV show called Person of Interest? Okay. So I am 100% sure that that TV show was inspired by what Chicago did. So Chicago created this, using machine learning, they created this strategic subject list or heat list. So it basically identifies people that they believe, the algorithm believes, would be involved in a violent crime. So either you are a victim of a crime or you are the person committing the crime. And so Chicago actually sent letters in the mail to these potential victims or potential criminals. And some even had police officers visit their homes. And so the backlash from the community, it did not go over well for Chicago, so they stopped the program. But I'm pretty sure they're still experimenting and trying to figure out how they can use machine learning to predict and prevent crime. So pre-crime in 2018 is called Predictive Policing. And Predictive Policing uses machine learning. So when you combine predictive policing and machine learning, what do you get? This is what you get. This is our case study for today. So his name is Sam. Don't laugh at me. I just happen to name all of my AI programs that I create. So his name is Sam. SAM stands for Suspicious Activity Monitor. Okay, so SAM is a predictive policing machine learning algorithm that I created using Amazon machine learning. So the way SAM works, anyone walking down the street can take a picture and tweet it to SAM. SAM then uses computer vision to pull attributes from the photo about the person. So age, gender, some additional information from the tweet. And then all of that information is then sent to Sam's machine learning brain. And so that brain looks at those attributes. I trained him on Georgia Bureau of Investigation, GBI, so he only works right now for the state of Georgia. That's where I'm from. I trained him on GBI data, past crime data, and he uses all of that information to make a crime prediction. And so that prediction is then sent back to the user as a tweet. And so the user may see something like, you need to run for your life, or you're safe, there's no crime about to occur. And so that is the case study that we're going to crack open today and walk through how to create that using Amazon machine learning. So just to give you a quick demo of SAM. So let's say you have a Twitter account, and I'm giving myself away. I love reggae. But let's say you have a Twitter account and you want to send a tweet. So you tag Sam and you put the county and the state. And then the photo that you took, you include that in the tweet. Okay, so now in the background, there's a lot going on. And in a moment, we should see a notification appear here. Yep. There we have the response. And so Sam's politically correct answer. I see several factors that indicate the likelihood of crime. Be vigilant. So that is our case study, Sam. So let's look at SAM's architecture. So as you can see, his entire, 90% of his ecosystem runs on Amazon Web Services. So he's totally serverless. So let's look at step one. So step one, you have the user sends a tweet with a picture, someone they believe is involved in suspicious activity. And so that is stored in the Twitter database. And then step two over here, within AWS, there's a Lambda. Who's familiar with Lambdas? So a Lambda, think of it like a function, a chunk of code that just runs in the cloud. And so there's a Lambda function that uses the Twitter API to retrieve the most recent tweet. And then that Lambda function pulls the photo from that tweet and then sends it to this AWS recognition service. Now, we're not really going to talk about AWS recognition today, but just know it's a computer vision service, and it allows a computer to analyze a photo or a video, pulling out objects, scenes, sentiment, just information from the photo. And so AWS recognition extracts image attributes. So specifically, it pulls gender and age, and also sentiment, whether or not the person is happy or sad. So that information is then sent to the machine learning portion of SAM. And so along with age and gender, I pull county and state, time of day, day of week, and month. And so that information is sent to the machine learning brain, and it generates a prediction that's sent back to the Lambda. And then the Lambda sends that prediction back to the user as a tweet. So today we'll specifically look at the Lambda portion and the machine learning portion. Okay. So how do machines learn? So there are three main ways that machines learn. The first is supervised learning. The second is unsupervised learning. And the third is reinforcement learning. So what does that mean? So with supervised learning, and this is the type of learning that we're going to really dig deep into today, because that's what SAM uses, supervised learning. So this is where machines are taught with data that already has the answers, okay? And we'll see this later with SAM. So we call the data with answers labeled data. And so SAM studies the labeled data to learn what crime looks like and what crime does not look like. And so in that data set, we have records that indicate crime, and we have records that don't indicate crime. So he learns how to predict crime based on analyzing that data. So when we talk about supervised learning, what types of questions can a machine answer? So there are three types of questions: binary, multiclass, and regression. So what does that mean? And those are called classification problems. So binary, a computer can answer a binary question. So this is more like a yes or no type of question. He's predicting one of two possible outcomes. So examples would be, is this email spam or not? That's a binary question. Will this person be a repeat offender or not? Is this person a good fit for this company? Will this person like this movie? Will this person buy this coffee flavor? And yes, I know my flavor is missing the U. Multiclass. So this is where you have one of many possible outcomes. So for example, is this item I'm looking at a toy, a movie, or a book? A computer can answer that question. Will this person like vanilla, mocha, or caramel flavored coffee? Computer can answer that type of question. And is this movie a comedy, a thriller, or a documentary? So this is where you have one of many outcomes. thirdly, regression. So this is where the computer is predicting a numeric value. So what will the temperature be in London tomorrow? For this new coffee flavor, how many units will sell? What is this person's life expectancy? Those are questions that computers can answer. So that's supervised learning, and that's what we'll talk about more today. Now, there's also unsupervised learning. So this is where machines have the data, but they don't have the answers. So they really have to go in there and just figure out on their own what's happening, what's going on. And honestly, this is what causes the most excitement and buzz in the industry when we talk about machine learning. And so Amazon machine learning does not support unsupervised learning. There are other tools that just came out on the market, like SageMaker. They released that at reInvent. reInvent handles a lot more complicated unsupervised learning problems. So when we talk about unsupervised learning, what types of questions can be answered? So clustering and grouping type questions, customer segmentation, recommendations, target marketing. So for example, let's say you have a large customer data set and you want to figure out who your customers are. You can use a machine learning unsupervised program to group and kind of segment your customers, find patterns and commonalities between them. So at the end of the process, you may have a group that's a working professional or a stay-at-home mom or a student. It helps you just cluster and identify your data. There's also reinforcement learning. So this falls somewhere between unsupervised and supervised learning. So the computer still doesn't have the answers to learn from, but it has the data. But at each predictive step, it gets feedback. So you see this a lot in robotics. So let's say you have a robot that's trying to make its way through a maze, and it hits a wall the first time. Well, the next time it knows there's a wall there, so it doesn't make that same mistake. So that's reinforcement learning. It's where the machine learns from mistakes and it adjusts it for the future. And so I think that's a great life lesson. So now let's talk about the machine learning process or the data science process. So once you formulate the problem or the question you're trying to answer through machine learning, the process is basically the same. So first, and we'll look at all of these in detail. First, you have to get your data. You have to have your data, and then you have to explore and understand that data. Then you prepare, do any data transformations, and then you load the data, and then you train the model. So this is that whole learning process that I mentioned to you earlier. And then you evaluate and optimize the model. You enable it for predictions, and then you start using it. Sounds very simple, right? So now this is where it gets fun. So now we're going to look at using Amazon machine learning to go through that machine learning data science process I just explained to you. Now, Amazon machine learning is a service that makes it very easy for developers from all backgrounds to create and utilize machine learning models. So, for example, I told you guys my day job, I'm basically a Java developer, but over one long spring break week, I was able to use Amazon machine learning to build SAM. And so that just goes to show how easy it is. Amazon machine learning provides wizards, visualization tools, and it allows you to use machine learning without really having to get in there and understand all of these complex algorithms and technologies. So it is a very neat service. And once you've created your model, basically SAM, you can enable an API endpoint so that any application that can make an HTTP requests can use your model to make predictions. So it's really, really cool. So the first step, that's obtaining your data. So you need to have data that you can teach the computer with. And so for me, I was looking for crime data. And so luckily, GBI, Georgia Bureau of Investigation, they have a website where you can go in and download past crime stats. And I was very surprised when I saw that all of this information was readily available online. So I went through the process of downloading multiple files. And then I had to go through the process of combining them into one file and then really just exploring and understanding the data. So at the end of the day, the model that you produce is only as good as the data that you feed it. So it's very important that you understand the data. And so what I did, I went through and I used BI, business intelligence, initially, just to understand what does crime look like in the state of Georgia. And so I'll have some charts to show you, but here this is just a summary of vehicle theft by county. And then here, this is a breakdown of the different types of crimes per month in the state of Georgia. And so I don't know what it is about August and July. Maybe it's the Georgia heat. It just makes everybody go crazy. But August and July have the most crime during the year in Georgia. And then this is a breakdown by county. So if you're ever in Georgia, stay away from Fulton County. This is Fulton County over here, all this crime. Now, if you want to come visit me in Fayette County, where there's no crime, basically, Fayette County is a nice place to live. I'm glad I made that choice. But this just helps me understand how crime breaks down by county. Okay, so what did I learn from the data? So there's a lot of burglary in December and January. I'm assuming that's because it's around the holidays and you need money to buy Christmas gifts. I don't know. But December and January, a lot of crime. Most assaults are committed by 22 to 29-year-olds. Vehicle thefts peak in August. Again, that's a hot summer month. Most vehicle theft committed by 16-year-olds and under. I guess they want to go joyriding with their friends. I'm not sure. And sorry, guys, it says men conduct more crime than women. And there are certain counties that have way more crime than other counties. Okay. So the next step is to actually prepare and load your data. And this is honestly the most time-consuming part of the process. I had to go through a process of cleaning up the data. And then also I wanted to break out the data. So for example, some of the crime data that I received from the GBI, it had a date. But I wanted to break out the month so I could find patterns amongst the months. And then the day, so I wanted to see if certain crime occurred more on certain days of the week. So I had to go through and manually break that out for all of the records. And so this process of going through and breaking out and transforming the data, it's really called labeling, because at the end of the day, in that file, I had the answer to the question I was trying to answer. So does this row show crime? Yes or no? Does this row show crime? Yes or no? And so the positive crime records I was able to get from the GBI. Now the negative crime records I had to create myself. So I had to teach Sam what crime does and does not look like. Now, in an ideal world, like if I lived here in the UK, I'd work with the UK Metropolitan Police. Does anyone have any contacts there? I'd work with them to use their data and train Sam on their data. So I would have real data from the UK Metropolitan Police showing crime, maybe arrests versus convictions, and things of that nature. So I always say Sam is a case study. It's a prototype. It's something I created over a week, so he should never be used in a real crime situation. Just have to put that out there. Okay, so this is a good look at the file that I trained Sam on. So if you notice at the very top, I have what we call variables or features. So these are the attributes that are basically used to identify patterns in crime for the state of Georgia. So we have county, state, time of day, gender, age, day of week, month. And then notice here, this is the target. So this is the answer. And notice it's binary, so 0, 1, yes or no. And so like I said, this was really the most time-consuming process, creating this training data for Sam. So let's look at a few of the observations. So here's a row that has Cobb County, state of Georgia, night, male, 30, Saturday, August. Yes, that row indicates crime. So that's a positive crime record. A negative crime record. So Coweta County, evening, female, 50, Monday, August. So the negative crime records I created, and this row shows no crime. So that's the learning process for Sam. He looks at all of the records and he learns what crime looks like and what crime does not look like. Lessons learned. So the very first time I loaded the data and I went through the training or the learning process with Sam, the process failed. And it failed largely in part because I did not shuffle my data. And so going back to that Excel spreadsheet, I like to sort things. I like things to have order. So I sorted the spreadsheet by the committed crime. And so we'll talk about this later. But when we go through the training or the teaching process, typically how it works, the machine learning program will use the first 70% of your data to learn from. And then it uses the remaining 30% to test itself to see how well how well it's predicting crime. So because I sorted that spreadsheet, it threw that whole process off. And I saw this big red failure the very first time. So lesson learned, if you guys play around with Amazon machine learning, make sure you shuffle your training data. Okay, so now I have that data, the training data. I have to load it to a place where Sam can easily get to it, Amazon machine learning. And so who's used S3 before? Who's heard of that? Okay, so it stands for Simple Storage Service, and you can think of it like a file system on the cloud. So a place where you can upload documents. And so I uploaded the training data, that Excel spreadsheet, to Amazon S3. So now it's in a place where Amazon machine learning can get to it. So this is where we start the training process. So this is where the algorithm actually learns and studies and finds patterns in the data to produce what's called the model. And you may have heard me say that term before. I like to think of the model as really it's the brain of the machine learning program. So it's really the artifact that's produced after training, and you use it to generate predictions. And so I used, of course, Amazon machine learning. And like I said earlier, it makes it very easy for developers to build machine learning programs. It really takes away all of the complexities, and it makes it very simple. And so I always tell people Amazon machine learning is a great place to start if you've never used machine learning before. It's a great way to be introduced to concepts and then also tools. When you reach a point where you're very confident in machine learning, then I would recommend that you look at Amazon SageMaker. Like I said earlier, Amazon Machine Learning does not handle unsupervised learning and more complex type questions, but it's a great introduction. So the model, like I said before, it's really the important piece. I call it the brain of the machine learning program, and it returns predictions. So think of it like sending questions in and getting answers back or predictions back. So how do you create a model using Amazon Machine Learning? It's very simple. First, you create your data source, and we'll look at that. Sanity check your data, make sure everything looks right, and then you go through the training process. So from a screen perspective, the first step is to create a data source. So remember, I loaded the data to Amazon S3. So basically here on this screen, I'm pointing to that data file. So the data source is like a pointer to the data file on S3. And so once you point to that data file, you have to go through this data source mapping exercise. So for each attribute in that spreadsheet, what's the data type? So they have categorical, and that's like a list of values, and then numeric, that's a number, and then binary. So binary is, it shows the answer. If you guys remember here, that's 0 or 1. That's the committed crime. And so after that, the data source is created. So now Amazon Machine Learning can see that data file. And so the next step is to explore your data and understand it to make sure it looks right. So you click on this target visualization here, and you'll see a few charts. So here it's just showing you the amount of records that it found. It's a great way to sanity check to make sure your data loaded correctly. And then you can also see it on a per field level. So here I just did a quick sanity check. For example, day of week has 7 unique values. So for example, if this said 10, I know there are not 10 days in a week, so that means something is off with my data. So it's very important to just sanity check your data and make sure everything looks right. And then you click Create, Train an ML Model. And then everything magically happens behind the scenes. But I'm going to show you what happens under the hood. Okay? So you create and train that model, and you'll come to this screen here. And do you guys remember where I spoke about that 70-30 split? So it's on this screen where you really set that up. So the default is the model will use the first 70% of your data to learn from, and then it uses the remaining 30% to test itself to see how well it's doing. And so that's the default. You can customize it using this side of the screen, but I just left it at 70-30. And it's important to note, and I'll talk more about this, that after the training process is finished, you have your model, that model gets an accuracy score. So how well is the model at predicting? And so it's very important for you to analyze that as well. Okay, so the magic that happens behind the scenes for you when you click that button, there's a learning algorithm. And the way Amazon Machine Learning works, it basically picks the learning algorithm for you. But let's talk about what is a learning algorithm. And so it's a part of the training process, and it consists of 2 elements. A loss function, which is the penalty that's incurred for guessing incorrectly. And then there's the optimization technique that seeks to minimize loss. So during this training process, just think of it like making sequential passes over the data, analyzing the data, finding patterns, trying to minimize loss, and really get to a model that is good at making a prediction. So the learning algorithm, really, it uses SGD, which is stochastic gradient descent. And it's just really, like I said, it's making sequential passes over the data to produce this model. So under the hood, like I mentioned, Amazon Machine Learning automatically picks the learning algorithm for you. You don't have an option. You can't change it. So if you're trying to solve a binary problem, it uses what's called logistic regression, and that's what SAM uses. If you're trying to answer a multiclass, remember that's one of many, it uses multinomial logistic regression. And if you're using regression, that's that numeric value, it uses linear regression. So Amazon Machine Learning really only supports linear-based models. But there again, all of that is automatically chosen for you underneath the hood. You don't have say over what happens, okay? And so once you click that button and it creates your model, all the magic happens, then it's really important for you to evaluate and optimize that model. So how well does that model perform? And so Amazon Machine Learning assigns a quality metric. It's called the area under curve for binary, AUC, and we'll look at that. And so it's up to you to really understand how well your model is performing, and then you have the option to adjust it for your tolerance level for errors. So let's look at that. So for binary, it uses, the quality metric is AUC, area under curve. And so for multiclass, it uses something called a confusion matrix. I guess that's how confused is the model, I don't know. And then regression, it uses root mean square error or mean absolute percentage error. So all these fancy mathematical terms. So for SAM, he uses area under curve. That's his quality metric. And when I first started learning about this, I was like, okay, so SAM actually grades himself. So that's like me grading my homework. I would always give myself 100. But remember when I said that 70-30 split? So it's that last 30% Sam uses to really grade himself to see how good he is at predicting, because he already has the answers. Okay, so Sam's AUC is 0.897, which is really good because the range is from 0 to 1. And so when we talk about AUC, the area under curve, it basically counts how many times 4 particular things occur. So if you see at the bottom, we have this true negative. So that's where Sam predicts 0, no crime, and he should have predicted that, so it was right. And then we have this thing called a false negative, where Sam predicts a 0, no crime, but he should have said yes, a crime. So he failed to predict a crime. And then there's this false positive, where Sam predicts a 1. He's saying, yes, there's a crime, when there really isn't a crime. And then the true positive. So that's where Sam predicts a 1, and it was a 1. So because Sam's AUC was pretty high, I left it alone. I did not adjust the tolerance levels, but you can. So down here, there's a slider that you can move to adjust your tolerance level for false negatives and false positives. And you'll see all of these numbers change as you move the slider. So when we think about the model, Sam, there are 2 mistakes that he can make. One, that's the false positive, where he can say, yes, there's a crime, when there really isn't one. And that's the false negative, where he says, no, there isn't a crime, and there really is one. So what do you guys think is worse, false negative or false positive. They're both pretty bad when we talk about crime. It's really, and that's the tricky thing, it's really up to the developer, right? And so for me, it's the false negative. So when Sam thinks there's no crime, but there really is one. So for me, that's saying an innocent person is being victimized and the criminal is getting away. So for me, that's not really good. And so I could change my tolerance level to say, I will consider more false positives. On the flip side, that could be considered harassment. So it's really a tough call. It's a tough call. But just know that if you use Amazon machine learning, you have the ability to adjust your tolerance level for false positives and false negatives. So that's very flexible. Okay? And so that's it. That's all it takes to build a machine learning model with Amazon. Very simple. And now that you have that model, you need to use it. And you can use it to make batch predictions, so predictions in bulk, or you can use it for real-time predictions. And that's what I did with Sam. And so you can enable your model for real-time predictions, and then you'll get this endpoint URL that you can call from any application that can make an HTTP request. That's really cool. Now, I will say there is a cost to using Amazon machine learning. It does not fall under the free tier, unfortunately. And so there's a one-time fee that you pay whenever you create or train a model. And it's basically how much memory do you use, how long does it take to create that model. So there's that one-time fee. And then when you enable the model for real-time predictions, there's a fee, a recurring fee, just for having the model up. Having this endpoint available, there's a fee. And then every time you use this URL to make a prediction, there's a fee. So just to level set, to give you guys a baseline, when I created Sam, I paid about $1.12 US dollars. So it's very cheap. And typically, I'll leave Sam running whenever I'm speaking at a technical conference because I'm cheap. I don't like paying a lot of money. But the most I've really ever paid to have him running for a month is about $11. Now, the more he's used, the higher that cost goes up. But just so that you're aware, it's not a part of the free tier. Okay. And so the next step is to actually use that URL in an application. So let's look at that. And so now we're going to look at Sam's front end. Remember that Lambda I spoke to you guys about? So there's a Python Lambda, that's this piece here, that actually calls that URL. Do I have any Python developers in here? Cool. So, of course, like I said before, I'm a Java developer, but I love learning new things. So this was my very first time writing Python code, and I must say it was a lot of fun. I could actually get a lot more done in a few lines of code comparing to Java. So the code that I have developed, it's on GitHub, and that's the link. And so now let's look at the code. So I'm just going to show you the next 3 slides, the code, and then I'll break it down section by section in the following slides. So that's the first, that's the second, and that's the third. Okay, so now let's go section by section. Okay, so in that Python Lambda, remember that's just a chunk of code running in the cloud. Think of it like a function. I'm using the Boto3 Python library. So this is the AWS SDK for accessing Amazon services. So you can call AWS from Python using Boto3. So here I'm creating an ML variable, initializing it to machine learning, and then I'm using the model ID. So back in the console, when we generated that model, it gets a unique identifier. So you can find that in the console, and you'll need it in your code. And so here, this is the default Lambda handler. And notice here, I'm just setting those attributes that Sam needs in order to make a prediction. So this is just a quick way to test Sam. And then the response, I'm calling this get crime prediction function. Remember that API URL, and then I'm passing in the data attributes. Now you can omit some of these values, like if I didn't have time of day, I'm not required to pass that in, but then that greatly reduces Sam's prediction, his predicting capability. So I would recommend to always include all of the attributes needed. Okay, and so I save the response, and if I get back a 0 from Sam, he's predicting no crime. If I get back a 1, he's predicting crime. And so the response for no crime is I see no factors that indicate the likelihood of crime. For crime, I see several factors, and that's the one that we saw in the demo. Okay, so now let's look at this get crime prediction function. So notice in here, I'm calling the predict function on that machine learning variable, and I'm passing in the model ID, and then the record, and then the endpoint URL, and that gives me back my response in this prediction. So that's JSON that comes back, and the value, notice here, is stored in predicted label. So that's where I get my response back, 0 or 1. And then this is me showing the results of testing that Lambda in the console. And so Sam returns a 1, and I see several factors that indicate the likelihood of crime. And so you can test your Lambda through the console, and each time you test it, that's calling the URL endpoint, so there's a charge for that, just so you know. And so like I said, when you're not actually using this real-time endpoint, make sure you delete it so you don't have a big bill. So that's the red X. Okay, and so things to note. Data must reside in Amazon S3 or on Redshift. Your model can't be exported. And like I said before, it doesn't support complex problems when it comes to unsupervised learning, like clustering and grouping and recommendations. Oh, and that's the next bullet point. It just doesn't support that. So in the last few minutes, I do want to talk quickly about machine bias. And so who's heard of machine bias? Who thinks it's a good thing? Yeah, no hands. And so with great power comes great responsibility. So Amazon Machine Learning puts very powerful tools in the hands of everyday Java developers. And so when I built Sam, I wanted to make sure, at least from a race perspective, he could never be accused of racial profiling. And so, for example, let's say in his training data set, I included race. And every single time there was an African American, I said, yes, that's crime. So Sam is going to learn that every time he sees an African American, I'm predicting crime. So that's not good. So as developers, we have a moral obligation to make sure that the programs and models, machine learning models that we create, that they are really unbiased and fair. Because at the end of the day, it really could destroy someone's life. So you guys have a responsibility, as do I. So what's the future of machine learning? So Google recently announced they are no longer a mobile-first company. They are an AI, artificial intelligence-first company. So our reliance on artificial intelligence and things like machine learning will just continue to grow. And what's the future of predictive policing? Well, U.S. military surveillance will continue with what we call autonomous smart machines. And I believe that they will continue to get smaller and smaller and smaller. And so I'm just very excited to see where this technology takes us, really as a society. So what's the future of SAM? There are a lot of cool things I'd like to do with SAM. I'd like to make him more real-time. So right now he runs every 30 minutes. And I also have an IoT button that kicks off the Lambda. But using Twitter Streams API and AWS Kinesis, I can make the flow real time. So the second a tweet comes in, it flows over, it kicks off machine learning, and get a response back. Facial recognition. So Sam already uses computer vision, so he can potentially identify who that person is in the photo. And then potentially look at their criminal history, things like substance abuse, and that can help him make a better determination. Maybe one day kick it off with Amazon Alexa. That would be really cool, a fun learning experience. And then I'm actually working on this one, using a drone as the camera for Sam. That's really cool. So I know I've covered a lot today. And so everything that we've talked about, all of the sample data files that I use to train Sam with, and just the steps and screenshots I've documented here on this course, the secrets behind Sam. And I usually charge for that, but I'm leaving on Sunday, so around Sunday I'll turn the price back on, but right now it's free. So it's good to just, if you guys want to dig a little bit deeper and create your own version of Sam, you can use that link. And so that's it. I'd like to open the floor to questions. Oh, yes.
Just regarding the crime data, so you downloaded the crime data from Georgia police.
Yes.
But you needed some negative
Yes.
samples to train your model. How
Yes.
did you get the negative?
I created those.
Right.
Yeah, based on my understanding of the crime stats.
Okay.
Yeah, and so like I was saying, in an ideal situation, you would not want to create your own data, but I did it because SAM is just really a proof of concept to prove out what the technology can do. I have a dream to work with the Atlanta PD to actually have their data, like arrests versus convictions, and just have real data to train Sam on. But really, I created Sam just for the learning experience. I wanted to learn more about Amazon machine learning. So it's not like a tool that I'm trying to sell or make money on. It was just all about the learning. Yeah. Any other questions? Yes.
Did you ever test the model to see if its predictions were accurate?
Pardon me?
Did you ever test to see if the predictions were accurate?
I test and I play around, and there's a part that 70-30 split. So that 30% Sam actually used to grade himself. And so his score was 0.897, that was the quality metric. And so he's really good at predicting crime. Yeah, but again, I would never use him in a real life crime situation. Yes?
You basically use the crime data, right? I mean, any situation, you should have all the demographic data in the whole city to do the machine learning.
Yeah, so I was able to download all of that information from the GBI, the Georgia Bureau of Investigation, and it includes like race, it includes age, it includes gender, and all of that, like time of day, day of week, and all of that good stuff. Yeah. And I actually searched and I found somewhere for the UK data that you could actually download. I'm like, oh, that would be really cool to play around with. Yes?
Are you able to retrain? So if you retrain the model once you've got more data?
Yeah, definitely. So that there is that retraining process. So the very first time you create a model, don't think you're finished. As you get more data, you should retrain the model so that it becomes smarter and even better at predicting. Great question. Any other questions? Okay, so did I butcher the English language? I'm going to tell my husband that. Thank you very much. Thank you. You guys have been awesome.